So Coffee with an Expert is a monthly meeting series, 30 minutes every month to discuss digital manufacturing and smart factories with our GE experts. So thank you very much for joining us. See our schedule for the year and feel free to register for the sessions of your interest. We'll cover topics such as smart factory for discrete complex assembly or streamlining the shop floor schedule. And next month, we will talk about smart factory for the industry. Next. Today, we are joined by our experts to discuss operationalizing AI on the shop floor. Mitan Solanki and Davide Cipolla are experts from our business consultant team. They will give you an overview of the impact that AI could have on the operations on your shop floor. Mitan, over to you.
So hi everyone, Mitan Solanki, business consultant based in the UK, and I'm joined here with my colleague Davide Cipolla. Do you want to say hi, Davide?
Hey everyone. Good morning.
Yeah. So today we'll be walking you through the session as Magali described. So we'll just give a very brief introduction into GE Vernova if you don't know who we are. We'll also talk through some typical challenges that we're seeing when we're talking to a lot of manufacturing customers. And then walk you through some demos, and then talk you through a use case, and then finally we'll have some time for questions. So just very briefly, who we are. So GE Vernova, as part of the wider GE group, which has been around for well over 100 years, we are really the energy branch of an electrification branch of GE. We've been supplying software to many manufacturers, again of different types that you'll see here at the bottom. So automotive, food and beverage, oil and gas, even supplying power with our automation software, starting right from the very bottom where data is collected, all the way through to the enterprise where you have an enterprise view of your entire operations. We've got many thousands of installations across the world that are either delivered by GE Vernova directly or through some of our trusted partners and system integrators. And I think the key thing to mention here is that GE Vernova ourselves, we are manufacturers. So in GE Vernova we'll be manufacturing things like wind turbines or steam turbines. Those are part of our operations, and our software is used pervasively throughout a lot of these manufacturing sites and manufacturing operations. That's really true and bears testament to the value that our solutions bring and our software is providing, not only the market, but it's also something that we are highly tuned in leveraging ourselves to boost our productivity and our bottom line. So it's the software that we truly believe in. Just at a very high level, like I said, we supply software which allows you to connect to data coming in off various machines, various lines, various assets at that level 1, level 0, and then bring that all the way up through to whether it's an on-prem or an on-cloud, all the way through to where administrators maybe will be looking at some of this, or high-level C-level people will be looking at this data. So we provide solutions that either exist on-premise or on the cloud, or a hybrid of both. So that includes things like SCADA systems, which is really around sort of real-time control. Historian, where you can historize that data, again, that can span, as you see here, on-premise or cloud. And then layering that on top of that to build a lot more context around the different types of work orders moving through the plant, different types of functionality that you may need, such as traceability of where your product is. A lot of that is in the MES system, the manufacturing execution system. And again, that could be something that's on premise, that could be something on cloud with obviously seamless connectivity in between. And today we're going to focus more on the analytics side. So again, once you've got a lot of that data gathered, it's really good to start thinking about how can we think about optimizing what we're doing through leveraging data. And that's some of what we're going to talk through today a little bit as well. So let's think about some of the key challenges that we often see in the manufacturing space. So the first one is process variation. That seems to be a real I think, killer of the bottom line revenue that manufacturers bring in. For example, you'll always hear someone talking about, we use the same raw materials that we normally do to do the manufacturing run. We had the same sort of set points on all the machines on the line. We got a different result. Why is that? And the idea maybe is to get to some sort of golden batch and leverage that data. Sometimes there'll be bottlenecks that appear almost seamlessly or randomly out of nowhere, but there are usually some precursors to those bottlenecks happening. So the idea really here is to try and leverage data as much as possible, to try and give an inkling into potentially why some of these things are happening. Why is there a reduction in quality? Why is there an increase in waste? Why is there an increase in the scrap? And there's obviously sort of anecdotal knowledge from some of the guys and girls that work on the floor, but once you start boiling this down to data, you start to get to the root cause. And that's the other thing here. So trying to understand the root cause of downtime, or the root cause of these bottlenecks, or the root cause of why you're having bad quality. That's something that we're seeing manufacturers really struggle with. How do they do that without employing a data scientist? The moment you move into throwing your data at a consultancy, you run the risk of them actually not understanding the context of where that data is coming from. It's really, really useful to leverage some of the knowledge, decades of knowledge sometimes, that some of the process engineers have of the actual manufacturing line and the machines, the units, the materials that go through there. So really what we like to do is to try and equip the actual process engineers themselves with very, very simple and easy to use solutions that can help guide them through their own data. And this is where I think we see that we can help manufacturers to on ramp on this analytics and AI journey. So trying to leverage AI and analytics in a real way, and trying to make it easy for people to on ramp to. So just I guess a bit of a pulse point of what we see in the market. So a study was done in 2024, interviewing many manufacturers at that high level, to understand what are they doing, and are they starting to leverage AI analytics in a way. And 55% of manufacturers were definitely exploring AI, and 45% had already started to begin pilots. That could be very simple things such as document summarization or looking at manuals. But the key thing is that there's definitely a real uptick in the amount of customers we are talking to who seemingly we start talking about some of the level 1 or level 2 systems around SCADA and just connectivity, but within the same conversations we're already starting to talk about how can we leverage AI, how can we leverage analytics, whether it's shareholder perception, whether it's actually to tackle real problems on the plant floor. There is always now an open discussion about how analytics can be used. So it's really, really important, and it's growing fast. And one of the keys to that customers are realizing is that you need a data strategy. You need a modern data strategy. So a lot of the work that was done over sort of the industry 4.0 was around, especially 5 or 6 years ago, was really around trying to assemble and aggregate data in a way that was possible for analytics to be layered on top. I think we're sort of getting to that stage. Obviously, there are some customers that are a little bit behind, but there's definitely a path, and there's definitely a transformation that GE Vernova, for example, can take you on to making sure that your data is in-house before starting to move to applying analytics. And I think the other thing that's changed is the security perspective. So 5 or 6 years ago, if you were to ask a lot of manufacturers, are you happy to move your data into the cloud to do sort of big data analytics? A lot of them wouldn't even open a port or whitelist a port to send data to the cloud. That has come 180, and there's now a lot more benefit, obviously, of having data there, but there's a lot more reassurance with manufacturers around the security aspect, making sure things are firewall properly, things are sectioned properly, whether you're in a multi-tenant sort of mode or whether you're locking things down in your own personal VPC. So security really is tantamount. And I think all of these combined really mean that the grounds are ripe to start leveraging analytics. So on the right-hand side, this was a study that was actually done the year before, so in 2023. Again, really targeting a lot of the C-suite in manufacturing, large manufacturing organisations, and you can actually see here that at that point, 2023, 38% weren't doing anything, and the remainder were. So you can see that you've moved between 2023 to 2024, where almost every manufacturer is starting to do something with AI on analytics, as far as the survey say anyway. Whereas the year before, we had almost a third doing nothing. So you can see year on year, this is a huge space where a lot of manufacturers, let's say, have started to move up that technical maturity curve, where they have started to get some of their data together, and they now want to leverage analytics. And I think the thing that we hear the most, especially in what we hear, is that Gen AI is good, but how do we apply it? And that's the key thing at the moment. The big buzz is around generative AI. Things that generate new text, things that generate images, things that generate video, and these large language models. But I think we have to sort of think a little bit when we're talking about manufacturing as to how do we boil this down. So under the umbrella term of AI, there's a lot of statistical techniques that have been around for a long time. There's things like neural networks, there's machine learning, there's deep learning, and the large language models that we see are a small subset of that. And if you look here on the table about where Gen AI, you would say, is effective or not, it's really, really good at generating content. So its usefulness is really high in generating content, conversational UIs. It's not so good at prediction and forecasting, although that may start to improve in the future. But if we go into machine learning again, which is a subset of artificial intelligence, again, it's been around for at least 15 years. The ability to do things like prediction and forecasting is really, really high. So if we're talking about analytics on the shop floor, machine learning is definitely a lot more useful than something like generative AI. Generative AI really, the machine learning when it comes to generating content is not a best fit. So I think as a manufacturer, you have to sort of look at the use cases, look at what it is that you want to gain out of applying analytics, and then just choose the right fit. These are all under the umbrella term of artificial intelligence. So you would be leveraging them if you use machine learning or neural networks. And again, what we want to do is to try and show you how straightforward it is to leverage these tools and make it easy for process engineers to get along that journey without having to be data scientists. So really, again, just going back to those challenges very quickly, we want to understand process variation. Again, that kills the bottom line. We want to move to a stage where we're reducing that process variation, try to leverage some root cause analysis through going through the data to get them to within some acceptable specification limits, and then at the very end start to optimize that process. So whether that's done with a human or whether that's done in an automated way, that's where we want to go. So very quickly, I'll just move into a demo here to show you. So Davide here is our process engineer. And I'll be here our transformation lead. So Davide, I understand you have some issues that you want to tackle.
Yeah. Hey, Meetan. Thanks for meeting me today. As an organization, we've been using GE's Simplicity SCADA for many years, and it works really well. It's a brilliant SCADA. It allows us to monitor and control what is going on in a reactive way, but can we move to something predictive? And I give you an example. We also have an MES system. We manufacture, we manufacture tins of food in various lines. The context of what happens is in the MES, these lines now and then they go down. Machines stop, they stop working, or for whatever reason. It would be great to have some insight on when this is going to occur. So, can we leverage AI and analytics in this context?
Yeah, absolutely. I think we can certainly show you that. So here we've got an example, for instance, where we're monitoring various units on a food packaging line, and essentially what we've got sort of 24 units across 3 lines, so 8 units per line, where we have a rinser, filler, capper, labor, sealer. And the idea here is to try and predict when some of our key units are going to experience some downtime. The key unit for us on this food line is the filler. When that machine goes, we know we're going to have some issues. And the idea is to try and look at some of the other ancillary units that are on that line to try and predict when that one is going to fail. So we can see here that we've got 2 predicted impacts of downtime that may potentially occur. So if I look along line C, we seem to be okay. If I move to line B, okay, we can see we've got some issues that are maybe starting to emerge here. So we have a labeler here, right? This is actually a little bit further down the line, but if I look at this labeler, it says that there is a faulty sensor on that labeler, and it's predicted to impact our filler here. And it's predicted to impact it in 33 minutes with a 45% probability. And if I then move to the actual filler itself, it gives a little bit more information. And again, the same data is here. There's an impact coming from the labeler itself. So that's the fault location. It's going to impact in 33 minutes with a probability of 45%. And the actual fault reason is predicted to be a depalletization. Right, so that's potentially what's going to kick this filler over. But the operators on the line have got some time there to react. You can also look at some notifications here. So these are general alarms that are coming in from the system. And we've got these yellow ones here, which are actual predictive alarms. So it's actually predicting that there's going to be a malfunction, again, in about 33 minutes. So just in general, there are ways that you can start to think about moving to predictive.
Okay, so if I understand correctly, you have a real downtime, which is of course managed as usual, but you also have a predicted downtime, which means the machine is not actually down yet.
Yep.
But the system is telling me it's going to be down and due to another machine being down at the moment.
Yep.
And he also tells me when this is happening.
Sure.
Is that fine? Is that correct?
Yeah, that's correct. Yeah, and the way it does this, it really looks at, like I said, you've got 8 units on a line. It will be looking at the other 7, right? And what it's doing in the background is built a model, again leveraging historian data coming in from SCADA, data coming in from some of the reason trees, data coming in from the MES. So the downtime table within your MES system is really crucial for this. So it's really good to have an MES system to help build the context of what's going on that line as well. And it will build a model using some of the other data points to try and build a relationship between those ancillary units and the main unit. And it will then start to understand the behavior between all of these different units. And that model will then fire and give you alerts when it's needed. And that's it.
Okay, so this is really great. It's great help for our supervisors to use this information and plan maintenance according to what is the status of machines and what is going to happen without waiting for the machines to stop. So that being said, this is great, but now we have this information is useful to preempt the issues, but how can we get insight about what is the actual root cause of the issues and where the process is going to be? Can we also leverage AI and analytics for that? And we go to our case. We are packaging the food. We are using the sprayer to make a uniform and consistent particle size in the soup before canning. But of course, that doesn't happen. So we have poor quality sometimes. Can we use analytics, for example, to understand why that is happening and kind of improve things?
Yeah, for sure. I think we can. So let me just move to an example here, and thanks for showing. Thanks for sharing some of your data as well. So what we found when looking at your data on the food spray dryer is, yes, you have an issue with the inhomogeneity of these particles, right? You want to create a consistent particle size because again, it can lead to poor quality product. But we also noticed that there was a wild variation in your dryer exhaust temperature, right, on this particular unit, which also means that you're using more energy, right? So we want to bring this under control to obviously save you cost from the energy utilization perspective, but also then from making sure that your customers have a consistent product. So if I look at your data here, it's very, very, very easy to see some of the variables that you've got here on this food spray dryer. And I've just got a summary of the statistics here. What I want to do is very, very quickly create a machine learning model. So your data is loaded. Yeah, here it is. Here are all the running values.
Yeah.
What I'll do is just within a couple of clicks create a model. Let's move some of the data out that we don't think you're going to be using. Let's just with a click build a model. So in the background, what this is doing, this is building rules around the data and trying to build a relationship and to try and understand and build a model around this problematic exhaust temperature that you have, to try and use some of the other variables to understand what influences that model the most. So if I move to here, I'll just describe what's going on here. So what we have here is a a model where you have a blue line here, which may be a little bit small to see, but you have a blue line here, which is showing actual data coming in. You've got a purple line here, which represents the model, and the model is a very good fit. And what you can do here is you can look at all the other variables besides the exhaust temperature to understand what's going on. So for example, I can take the dryer pressure, right? If I were to increase this or move this, you can see here this orange line moving. That's where the model is predicted that it's going to move. If I take, for example, the inlet air temperature and I start to move that around, you can see where the model is predicted to be. So again, you don't need to do this in real time on your real line with real machines running. You can build a model of a certain part of the process, for example, and say, what if I was to increase the pressure, or what if I was to increase the temperature, or what if I was to open this valve here? What would happen to the final targeted variable? And you can also start to look across here. So if I can move a ruler along here and start to visualize potentially what are some of the causes. So when the temperature is really high, we know we've got inlet pressure that's high, another inlet temperature is high, which is something you would expect. So the idea here is that you're just building a model to try and query and interrogate what's going on.
Okay, this is good. And can we get some insight about why this could be happening and the behavior works like this?
Yeah, absolutely. So what you can do, you can export the model that was just created within a couple of clicks. You can then start to input data from a live OPC source, a historian, or historically a text file. And then you can work the data through the model, and then you can output things like predictions and causes, right? So every time, every 10 seconds or every minute or whatever it is, you can have the model essentially pumping out where based on the input values, where the model is predicting that the values are going to be, but also the causes alongside that. So you can output a list of causes to say the most influential variables that influence the model at this particular snapshot at this point in time, every 10 seconds or every minute, was this. And that means the operator can essentially look at a dashboard. So the outputs from these causes can be moved to a dashboard, for example, output to a historian, output to a SQL table, output straight away to your PLC to actually self-optimize if you want to in real time. It can do that. So the operator can then work on what are some of the recommendations that are coming off that system. Another place where you could use some things is an optimization block. So you could have this automatically with a non-linear optimization loop and make the changes automatically to the PLC. And just moving along the Gen AI thread, if you wanted to involve some Gen AI in this, you could go to your favorite LLM. You can use Gemini or ChatGPT or Bedrock, and you can ask it to create a script, a Python script based on some of the data that you've thrown at it. You can move that Python block here. If I open it, you can copy and paste the code into there, hook up the variables, and here you've got a real-time execution of an analytic. So even if you've developed the analytics somewhere else on the cloud, or elsewhere using Gen AI, you can use this CSense here as a tool to execute that, because it's no good an analytic just running on the cloud. You can bring that analytic, as it was, bring it on premise and have it directly hook up to your PLC or hook up directly to your historian to output those changes. So it really becomes a really powerful execution engine at this stage. So
yeah, that's really impressive. And so let me summarize a little bit what we've seen today, because this is a lot of value for us. So if I want to to say it in few words, we have seen that the system can help our people understand the dynamics of the processes and anticipate the issues. We can have an understanding of what is going to happen, when the machine is going to be down. We can get alarms and understanding how alarms and downtimes are related to each other. But at the same time, we can have an understanding of why things happen, why issues happen. So this is the first step to reducing the variability in our process. And the process engineers in the company can quickly rely on that information to identify in which area we want to be, which area of the process we want to be, in order to have the best performance. And that, you've shown it in the last minute. Speaking about the performance, there is also the capability to drive operations by recommending what the set points should be in order to get the best possible performance out of our process. So you've shown it in the system. You've shown that you can drive the dashboard with recommendations to the operator. But in the same way, we can have a closed loop and directly drive the controllers of our system to get out the best performance out of it. So this is a really impressive show. Thanks, Meeten, for showing this.
Yeah,
Really
no
impressed.
problem. No problem. So let's get through to a customer story very briefly. So again, just sticking with the sort of the food and beverage theme, we worked very closely with a manufacturer who had actually three real challenges. First, they were delivering poor quality product to their customer, and their end consumer were complaining, and actually, again, that was just around the quality of the product that they were experiencing. The other challenge that they were experiencing was really around they were losing a lot of bottom line. So they were putting too much of their product into the packaging, and they wanted to understand why that was. So there were a lot of inconsistencies with sometimes there was too little maybe product in the packaging. Consumers were unhappy. Sometimes there was too much. So they wanted to get a grip of that. But one of their key challenges was around the actual material. So what they wanted to do is to say, look, can we save on the material cost of some of the product we're producing by maintaining the same quality? And actually going through the analysis, they realized that they can move to some cheaper suppliers for similar raw material, yet still achieve the same quality at the end. So again, resulting in a really, really big cost saving. So actually with this particular manufacturer, we managed to save them a lot of money. One, from the better quality, so less complaints. Two, from putting less product in the packaging, making sure the right amount was there at the right time, but also using sort of cheaper materials, but maintaining the quality for the end customer. So all of those combined ended up saving this customer a huge amount of money. So that's just one example where we've used this. So with the time we've got left, do we have any questions?
Yes, thank you very much for this presentation, Davide and Mitan. A lot of content condensed in very few minutes. And we have received a lot of very interesting questions, so we'll try to cover them all. And I see somebody clapping. Just to say that if you have more question or more specific question, feel free to contact us. And you have here the email of Cataldo Tarantini, which is our colleague. We will be very pleased to receive your inquiry and share it with the colleagues. So first question, is there out-of-the-box analytics for manufacturers?
Yes, absolutely. So one of the things that we wanted to do really within GE was to help customers just get on ramp. They didn't need to go away and do any scripting or to build anything themselves. We understand that there are some very common use cases that come up again and again. So anytime a customer is purchasing a SCADA system, for example, they get some of these out of the box analytics based on CSense that you saw there. So the first one here is called alarm pattern monitoring. So that basically creates a model of a lot of the alarms that have gone before, and it allows you to understand which alarms are going to be coming next. It tells you when they're potentially going to be coming and with what probability. So straight out of the box, when you get a SCADA system, you get this predictive template automatically. There's also one called Sensor Health. So that allows you to build a picture of your sensors over the past year or 6 months, whatever. So when a new value comes in, it understands, is this an anomalous value? Has my sensor flatlined? Is the instrumentation down? Again, that's value that comes straight out of the box. It doesn't cost anything extra. And a historian, for example, we have something called time series forecasting. So that really looks at your historical data, and it will forecast 24 hours ahead of where a potential temperature is going to be moving or potential pressure is going to be moving to give you a window into the future. Again, this is coming out of the box when you have a historian. So yeah, there's lots in the box here. We can go into more detail, but I know we're short of time here.
Yeah, we are short of time. We'll try to address a couple more of questions. To utilize best the predictive model, should we already have MES, SCADA, data sources, or is this system agnostic, non-GE product, working with non-GE products?
It can work with non-GE products, so it can work with raw SQL databases, but there are pre-built connectors for things like historian. We can pull in MES data as well from plant applications or smart factory into here. It just makes the transition a lot easier to stay within the suite. But the solution itself can handle data coming in from a text file, for example, a SQL database, for example, historian as well, for example. So it's not locked down. That's the key thing.
Okay, a couple more questions, and I see more questions coming, so we'll make sure we can answer all of them offline as well. And
Sure.
I repeat, you can also reach out to Cataldo if you want. So a question regarding the criteria for selecting assets for machine learning or AI. What's the approach?
So I think you typically want to have a target for let's just say on a line, a machine that causes you particular problems, right? There are some smaller machines on a line where you've got a manufacturer will have spare parts, or they'll have operators that can very quickly go in and fix things, right? I think the key thing happens is when you have large rotating machines that generate 50 to 200 or 400 tags worth of data, these large machines that have a lot of complex sub-assemblies within them. If that was to go down or that was to break, that would mean your line is down probably for a day, maybe multiple days, where you've got real challenges. You may need to call in an external contractor. You would say target that machine and understand what parameters impact that machine. So look at some of the other machines on the line that are surrounding it to try and give you a precursor as to what's going to happen. So you choose a target machine, use some of the other machines that are on the line and generate data, and then when you're doing the machine learning, you will start to find some correlations in what's going on between various sensors along that line, and again you can build a model behind that.
And on top of what you said, Meetan, I want to add, we can not only we model the asset behavior, so we can model the digital twin of a machine, but we can model a process twin which goes across several machines. So all the data that you have can be leveraged to build a better model, a better representation of the whole process, which will give you additional insights about the root causes of something happening on one machine being, generated by something else happening on another machine. So I think it's depending on the use case you want to tackle, it can be valuable to put all the data you have in just to understand how the machines and the data are correlated to each other.
Yeah, and just to finalize with the final, anytime you have a mathematical problem, this is where on a process, for example, this is where you would apply it. So you may think as a manufacturer, hey, if I sped my line up by an extra 10 seconds, right, or I moved it forward an extra 1 meter per second, how will that affect the final quality of my product? Can I speed through more product, increase the yield without sacrificing the quality? Those are classical constraints and variables that you start thinking about. And again, you can apply it to almost anything within your line in terms of a process. Anytime you think of a constraint or a challenge, this is where you would apply and try to find a solution for it.
One last question, which I personally really liked. It's about who are the users. So who would be the users to these models? Process engineer, reliability engineer, or production engineers?
I would say by and large, it would be, if it's a process problem, like I just described, it will be a process engineer. A production engineer could also look at it. Reliability engineer would most likely be looking at on a machine by machine basis, so looking to do some sort of predictive analytics on each machine. But all of them are more than welcome to leverage this, and we've seen all three of those different personas leverage this solution to get value out of it.
And one key point here is you don't need to be a data scientist to use the system. You have seen that we have data. The system makes it easy to digest the data, to put data together, combine the data, and build the models. So the data science is built inside the software, and what the user has to do is just look at the data in, let's say, the context of the process of what is happening and so on. So it's really easy to use, and it doesn't require you to be a data scientist at all.
So we're still receiving questions. Are you okay to continue online answering the questions?
Yeah, absolutely.
Yes? Okay.
Yes,
so just to let you know that this session is recorded, and we will share the recording by email. If you can stay on the line, we'll continue answering the questions. And thank you very much for joining and for all your questions. So what are the use cases for refinery maintenance?
Refinery maintenance.
Yeah.
Refinery maintenance, yeah.
I don't think I can think of any. So an oil refinery. I guess it's oil refinery. I think
oil refinery, I mean.
Yeah, oil refinery. I think we can look into. We've got a huge catalog of customer references. I can't think of any off the top of my head, but I think we can go into our catalog, and that's something we can share at the end of the session, or point you to the website where we've got a lot of references across different domains. So I'm sure there'll be a refinery use case in there somewhere.
But I would say,
Great.
From the top of my head, anything related to predictive maintenance would make a lot of sense. So understanding when machines are going down and why. So the root cause analysis on the issues you might have, the downtime prediction, the alarm pattern model that we have as a standard that you mentioned before. So these are all use cases, like I said, from the top of my head. But of course, we can share the
use case.
Our set of references, and we can look into it. So you're welcome to reach out to us and discuss detailed use cases with us.
Yeah. So a good example is, we a lot of customers in the oil and gas industry use our Simplicity SCADA, again, because it operates at that really, really fast microsecond level, which is what you need sometimes in oil and gas. Because pressures can build up and explode very, very quickly. So out on the field, you're talking blowout preventers. In oil and gas, you're really talking about just high pressures on that plant floor as you're refining. So this solution is layered very, very frequently on top of Simplicity, again, to try and provide some of that predictive guidance. So, for example, if you're looking at alarm patterns, if you see an alarm start to appear, it will give you a time and a probability to when a potential next alarm is going to fire. So this layers very, very well on top of Simplicity, which is used a lot in the refining industry.
Okay. Another question related to predictive maintenance, I guess. Are these features available in APM v5.2?
So this is a different solution to APM. We're under the same sort of umbrella as GE Vernova, but this is a separate product, where asset performance management has its own way of doing some of the analyses than this. I would say that the key differences are APM focuses more on asset first. C-Sense here focuses more on process first. However, C-Sense is also capable of doing some analytics on assets as well. So I think that would be the best way to summarize this.
The question, can this kind of process map and predictive model be achieved by a simulation tool such as MATLAB? Is this also a possible alternative to Minitab? Yeah,
so we come across a lot of customers who have leveraged Minitab and MATLAB and have probably been using it for maybe 15 years. This provides a level up, and we've got a lot of customers who migrate from there to C-Sense. Almost all of them migrate to C-Sense. Again, mainly because of the connectivity, mainly because of the ease of use. With MATLAB, you typically have to go to the C language to script, right? With this one, there's almost no scripting involved to achieve the same product. And again, as Davide mentioned, this is designed for process engineers. So process engineers really are busy in the mode of firefighting all the different challenges that are happening across the plant floor. All they want to do is very quickly load in their data, have a very visual space to very quickly understand what the root cause is, and then get to action, then simulate and then deploy. And they can do this within a couple of clicks. And again, the key thing here is that you've got the pre-built connectors already to interact with many, many different systems that you just drag and drop to SQL, Excel, text files to different historians, not just GE's historian, and to OPC. With those other solutions, you have to oftentimes build those connectors. Sometimes they're open source, sometimes they fail. This is a productized solution where once you have some outputs that come from the model, you can shoot them straight into historian. You can shoot them straight to OPC to then have an actual impact on your PLCs that are on the plant floor in your control room. So this is really an integrated software that is hardened and industrialized.
And I also want to say another thing, like MATLAB and Minitab often are used by data scientists directly. If you are using such a system today, it doesn't mean you have to throw your analytics away. I'm thinking about any models you might have created in those systems. They can be leveraged by seasons. We have a runtime meet-and show. There is a blog for Python. We can even host ONNX analytics and execute them. So it's a system that is great for the process engineers to get results fast out of data, to get models fast, and to drive things and to get insights in a really fast way. But at the same time, if you have your, data analytics model that you have built over the years and refined and so on, it doesn't get lost. It can be leveraged. And again, the connectivity capability of this system for the industry, this is an industrial advanced analytics system. It's not a mathematical software. It makes everyone's life easier. You have blocks to connect to OPC, blocks to connect to Historian, blocks to connect to SQL. Bringing data in and data out is an easy task.
And last question, can we push intelligent alarm process, at Etera SCADA from GE to AI-based?
Sorry, you want to move, can you please repeat the question again, Magali?
Can we push intelligent alarm process at Etera SCADA from GE to AI-based? Etera SCADA.
I think the question is about interacting with non-GE systems, maybe sometimes. Yeah. And yes, that is possible. So this is an open system, and it's very easily integrated with the GE software and the GE portfolio. But of course, if you have other systems, we can connect with that. We can integrate with that. Leverage data coming from this system, but at the same time, write data back to those systems in terms of KPIs, predictions, and recommendations for the process and so on. Yeah, I hope that answers the question.
Well, thank you very much. I think we're all done with the questions. Thank you very much for joining us, the participants, and Davide and Mitan, to discuss this topic of operationalizing AI on the shop floor. So as I said, we'll share the recording by email, and we look forward to seeing you in the next Coffee with an Expert. Thank you. Bye.
Thank you. Bye-bye.